Okay, final question from the 2022 exam. So here we're looking at a couple of values and we're trying to use logical or move instructions to get the values in registers 2, 3, and 4. So we're starting with these two values. We're trying to get these three here, and we're asking you to write some small set of instructions, not to just put the values in with move W and move T, right? So asking you to basically combine these values using the instructions you know. So looking at this first one, so R2, we just really want to look at like what are we taking from R0 and R1, how does it combine? So you can see we have the CA in this column from R0, we have FF from R1, we have FA from R0, and then we have FF from R1. So really we want to think what instruction allows us to sort of take the values where there's a 0 from R1 or from R0 and we get the F's from R1. And if we do an OR instruction, R2, R0, R1, that OR instruction is going to sort of, copy over the zeros with CA, copy over FE with the FF, copy over zeros with FA, copy over the DE with FF, and that gets us that whole value. So same thought for value R3. So we're looking and we see that there's a CA here, and that's coming from CA there probably. And we have a bunch of F's to the left of it. So there are multiple ways to get this, right? We could just like pool that CA somehow and then zero, extend the one. So we could do like a shift and then a signed extension potentially. But we can do that in one instruction if we just do an arithmetic shift into R3 from R0 and by 24, right? So that's going to shift us over from where it currently is by 24 bits or 3 bytes worth of data, right? That'll move us over enough to put the CA in that position. And as we shift, we're adding ones on the left because it's an arithmetic shift. It's keeping the sign the same. So that's that value, that's this value. The last part, there are a couple different ways to do this. It really depends on how you're feeling. The easy way probably, we need to get the DE here, that's coming from there, right? And then we want F0, 0, FF is coming from there. So really we just need a way to sort of get that DE in the right place and then combine it with the value from R1. So my easy way to do it is LSL into R4 from R0 by 24, right? So again, we're just taking that value, moving it over to here. And LSL, because we're going left, we just fill with zeros on the right. So that would end up giving us effectively OXDE 000000 in our R4 register. And then this part, well, we can do the same thing we did in the first step, and we can OR together R4 now, which looks like DE0000 with the value in R1, and that'll get us our final result. Other ways to do this, so alternatives for 3. First alternative is we can do a move into R4 from R1. That'll get us now R4 equals OX00FF 00FF. And then we could do a bit field insert. So bit field insert can take this rightmost part of R0 and pop it into R4 at that location. So that would be R4 is our destination, R0 is our source for that. Our least significant bit that we want to insert to is 24. Our size of the insert is 8. And so that if you look at the BFI semantics, that'll take those bits from there, move it up to there. Finally, the very quick way to do it, last solution that we can use, is to do this same thing that we did up here, but in one instruction using the barrel shifter. So we can do an OR into R4 from R1, and the order of operands is important here, and R0, so we're ORing those together, but we're going to add an LSL 24. And it's important to note that these two things are sort of paired together, right? And so the R0 is going to get shifted by 24 before we do the OR operation. And so that puts it into the right place. It basically gives us this is equal to that, right, value here in total, then we're ORing in R1 and that puts it in the results. We can actually do this in 3 instructions if we're clever about using the barrel shifter. And then last one, we'll just look at the bonus real quick because it's kind of interesting. Give an instruction and inputs if needed that produces the flags NZCV equals 0100. So I think this was here basically to try to break the habit. I think a lot of people want to do something like, you know, OX F F F F, right, plus OX 1, right, in 16 bits. We could, you know, extend this further, 00001 F F F, right. We add those together, and that gets us OX 000000000, right? It's -1 plus 1 is what we're doing effectively. But of course, when we do that, there's a carry out, so we can't get a 0 in that by doing an addition. So the trick is we're not doing an addition here for this. We could do something like move S R0 0, right? Because the result is 0, but there was no potential for a carry or for a unsigned or assigned overflow, and the result's not negative. We can actually never have n equals 1 and z equals 1, right? Because that doesn't work because n is or 0 is a positive number in 2's complement. So we could do something like this. We could do an and S of R0 with 0 as well, right? Anding something together with 0 is going to lead everything to all be zeros. So a couple options there. Again, this is sort of just a neat trick of a problem. So that's it for the exam. Good luck with your studying.